Okay, great. All right, everyone, welcome so much for coming today for our event. My name is Mike Jadoo. I'm the Diversity Committee Chairperson and also Rep at Large for the Washington Statistical Society. And I'd like to again welcome you all to the Careers in Statistics and Data Science panel discussion. So I want to start off by saying thank you to Rachel Saidi and the Montgomery College Math, Statistics, and Data Science Department for partnering with us for today's activity. And just a little bit about the Washington Statistical Society. We're a chapter of the American Statistical Association, and we're based in Washington, D.C. While the first American Statistical Association started meeting in the Washington, D.C. area, which took place in 1896, members living in the area also was holding meetings for scientific discussions, and that just started culminating to the Washington Statistical Society coming to fruition. And it became a branch of the American Statistical Association and officially became a chapter in 1935. So WSS is one of the largest chapters in ASA with over 900 members currently. And periodically we offer numerous seminars and workshops, professional networking activities, and opportunities to engage in service by increasing the level of quantitative literacy in area schools and motivating and developing the next generation of statisticians and also data scientists as well. We welcome you to join our society, and our membership rate's very inexpensive, especially for students. Students' rates are $3. And what do you get for $3? You get your subscription, you give you access to the members' email list, email notifications, where you get job announcements from both the private and public sector. And also there's short courses that we host throughout the year. And we also have free webinars on occasion on topics related to statistics, federal statistical agency operations, and also data science topics. And yeah, those also are announced on our email list as well and on our website. And you also get a discount on our rates for our different social and professional workshops that's offered throughout the year. So I just said a lot about WSS, and now let's get started with today's activity. So data science is one of the most highly paying jobs currently, according to Glassdoor and a data scientist website. Data scientists make an average about $116,000 per year. This makes data science a highly lucrative career option, but the path to starting or advancing data science or analytic careers is not always linear. Unlike most traditional jobs, you don't necessarily need to have a technical bachelor's degree or master's degree to become a data science professional. You just need the right skills and experience. So in the past decade, the availability of data and demand for data science skills and data-driven decision-making has skyrocketed. These careers have been pushed further into the spotlight by the drastic shift in business operations and consumer behavior caused by the COVID-19 pandemic. Statistics, analytics, and data science are now cemented as essential navigational tools across industries and functions. So today's activity, we have 4 panelists who will share with you their unique career journeys, which is related to this field. They will also provide you with some important points from their experience in order to help you meet your needs of clarity and understanding about the profession. First, we have Mark Otto. He's a statistical scientist at the U.S. Fish and Wildlife Service. He is also a longtime member of the Washington Statistical Society and current president. He looks over many different initiatives within the WSS. Next, we have Prima Roman. She is a data engineer at Navy Federal Credit Union. She also does a lot with Python and a Python module, the Python module Yellow Brick, by serving as a contributor. Next, we have Pragyansmita Nayak. I believe I'm pronouncing the last name right. She is a chief data scientist at Hitachi, Vantara Federal. She also does a lot with the data community DC and also at the several other meetup groups with a special interest and focus on data science. Finally, we have Alex Vercic. He is a data scientist and applied intelligence, I believe, see, he's working on applied intelligence for Accenture Federal Services. He's recently given a very good presentation at the Bureau of Labor Statistics using tidyverse for fraud detection. So we welcome our panelists today, and we want to start off with Mark Otto. Each of our panelists will give a 5-minute introduction to themselves, and then afterwards we will start opening the floor for questions. I have some questions here which will help us move the discussion along, and then we'll open the floor to all of you to answer your questions. So go ahead, Mark Otto, please begin. Thank you.
All right, thank you, Mike, and thanks for doing a pitch for the Washington Statistical Society. So I had a roundabout career, and I started out in biology at the University of California, Davis, and I wormed my way into a lake study lab, limnology lab, by counting phytoplankton. And that also let me on one project dive in Lake Tahoe every month of the year. Just wanted you to see that statisticians don't always sit behind a desk. But anyway, every research project and lab I did at Davis and stuff involved some kind of statistics. And I wasn't interested in statistics then. In fact, I took the usual bad statistics course. But later on, it did give me a domain that I was interested in to work on my statistics. So later on in North Carolina State, when my master's in ecology was stalled, I was encouraged to go into statistics. And that turned out to be a better degree. Many wildlife biologists and zoologists came back. They had their PhDs, but to be employable, they got their master's in statistics. And I think that's what a lot of you are doing, getting your certificate in data science. So I didn't have a math background, and all the math majors could derive the theorems and stuff like that. But unlike them, I sort of knew what all those tests were for because we used them in our research. I did my master's research on group size and line transect sampling, and I did it on beer cans. Graduate students were more interested in looking for beer cans than other animals. So my major professor was horrified, of course, but it did become a famous data set in wildlife biology. You can Google it. After that, I reluctantly took a job at the Census Bureau at the time series staff. Government seemed rather boring for me, but it actually turned out to be a great place to work. I was with 2 world-renowned researchers in time series, so I learned a lot. And each year we divided up our research, and they said, you're going to do this research, you're going to present it and go to the joint statistical meetings every year. And for a master's level student, that was really good, constant practice in communication and so on. So one of the things I did there was write a regression program in Fortran on regression and time series. And I even wrote I designed the input language and processor for that, because that I thought was something to make it really easy for people to use the program. And that may have been one of the more impactful things I've done. It's now in the X13 ARIMA seasonal adjustment program, and that's used by governments around the world 30 years later. So you may not remember Fortran. That was a popular language back in the dark ages. Another thing I did was develop an automatic outlier detection program. And the difficulty there is you're trying to figure out outliers, but the data is correlated, so you're not sure. So it was iterative and complicated back then. And I thought, oh, okay, the people are gonna, run the program, they'll see what outliers there are, and then they'll go do research and see which ones are the real ones. It actually didn't work out like that. I mean, they're automatic outliers. They go, oh, these must be the outliers. And those became the outliers. They put them in their analysis, and that's what ended up in the official seasonal adjustment. So it's sort of a lesson to think, you know, how your tools and stuff will be used, maybe not quite the way you thought. The last project I worked on was called SAPI, or Small Area Income and Poverty Statistics. And there we took census data, the current population survey, food stamps, and tax data, and combined them all together in a Bayesian model to estimate child poverty. And that was the first model-based official statistics, sort of a big deal back in the 1990s. So that was sort of the first government data science project. $50 billion of government money was allocated on those stuff. So that was one of the things that was sort of nice. In government, you know, maybe I wouldn't be in some wildlife nonprofit where I could say what I wanted about the environment, but I could at least be involved in informing the decisions that were made. That continued throughout my career. One thing I quickly did is I organized an exchange between me and another statistician at Statistics New Zealand, so he could come here and I could go there and work for a year. But I ended up taking a job at the Fish and Wildlife Service. It's good to make and take those opportunities when you can. So at the service, I worked on a aerial transect survey where small planes flew over North America counting ducks, and that was used to set the hunting regulations. That was part of something called adaptive management, and there we used data to inform a population model about ducks to figure out what would be the optimal hunting strategy. And that sort of took hunting regulations out of the back room, smoke-filled rooms, and made it sort of transparent science. And that was a nice way statistics informed policy. Later on, when one of my supervisors didn't know what to do with me, I worked on a national survey for bald eagles. And we used that survey to monitor bald eagles after we delisted them. And now it's used for permitting wind facilities. So again, information to inform policy decisions. Volunteer activities were really important in my career. I volunteer for the ASA and for the Washington Statistical Society on quantitative literacy, leadership activities, and mentoring. And I've got to meet a broad range of statisticians, and it's given me a different perspective on my job and stuff. And a lot of, you know, like activities where I can learn and grow in ways I couldn't just in the one job I have. So I encourage you to do that. Now, looking back on my career, you may think, I hope this hasn't been sort of the old guy talking where I say, I walk 5 miles in the snow and you guys have it easy. You know, in some ways, you guys, things have changed a huge amount in my career. When I started, there weren't personal computers, and you know, the computer I learned on was the size of a refrigerator with 2 megabytes of memory. But you guys, it's the other way around. Things are going to change a huge amount more, and you're going to have to be aware and look at that change and maybe make yourself a little more uncomfortable. So thank you for your time.
Thank you, Mark.
Long career in data science.
Thank you. All right, next up we have Prima Roman.
Hi, good evening, everyone, and thank you, Mike, for giving me the opportunity to speak tonight. My career also was kind of an interesting journey. So I am currently a data engineer at Navy Federal Credit Union, but I actually work with a lot of data scientists to actually help deploy their machine learning models into production. So I'm in effect a machine learning engineer. And yeah, my path wasn't quite linear as well. I started out as a data analyst at a startup way back when. This company was focused on online consumer behavior, when it was just kind of taking, the internet was taking off, and, people, our clients were interested in, learning how to, monetize, people's just, kind of observing their behaviors and try to figure out how best to, profit off of people's activities and understanding how they interact online. So a lot of my work was just, using, SQL to create business intelligence reports for our clients. I then switched over to a financial services company where we sold historical stock market data products to like big banks and other financial institutions, as well as retail investors and universities. And my job primarily became that of a software engineer. So I did a lot of Java development work, but also just still hands-on, SQL, just not to the extent that I was doing, previously, and definitely not a focus on business intelligence. It's more like keeping the data together, right, and just have and using the data to build our software applications. But because I started out as an analyst, I kind of had started a master's program in information systems, and I came across a course called data mining. And so at the time it kind of piqued my interest because it was in data, and that was sort of like what I had started in. So I was like, I should take this course just to check it out. Like, it sounds cool, and it was kind of like a precursor to a lot of the stuff that you see in data science now. I got to learn about clustering, classification, regression, pulling in feature engineering, what concept of training and testing and things like that. And it was very fascinating. But unfortunately, I didn't get to use any of that at my day job. So I'd kind of still whet my appetite by doing like little side projects over the years. I attended some hackathons as well. And through that, that point, I came across Python as a programming language and discovered that, that a lot of data science, this data mining is now called data science. And, there's this package called scikit-learn where you can do a lot of this data science work. So again, a lot of this was very interesting. And it was rather unfortunate that I couldn't do all of that stuff at my job because there wasn't too many like Java libraries to do these things. So, kind of then on the side was doing some of this work in Python. And then I came across a company called District Data Labs, and they were offering like basically it was like a 3 to 4 month program where it could work with other professionals to build data products. And it kind of looked like, this was my foray to try to get even more experience in data science and machine learning. So I signed up for it, and it was quite the experience. I learned a lot. I learned, particularly like we created a natural language processing data product. I got to actually work with MongoDB and some of these and the Node as well. So it kind of created a front end. So it kind of did like wind up wearing multiple hats, essentially. And through District Data Labs, I also participated in a couple of other of their programs, ultimately landing in the Yellow Brick project, which is an open source Python library for machine learning visualization. So I definitely recommend all of you to check it out if you're interested in data science and machine learning, because there's a lot of complex things that you're doing, and there's so much like iterative work that you have to do, and using visualization tools really helps you kind of through that whole process. So definitely recommend you checking that out. And then what I would also say, basically, I think, as you can kind of tell from my experience, like it's, you can, there's just so many different ways you can kind of come at, at this. And I'm kind of at the sweet spot of like where I feel like a lot of the experiences that I've had, over the years kind of help, get me to where I am right now. using the whole like between software engineering and the data analyst, and then just kind of getting more experience in data science has kind of helped me kind of get into this machine learning engineer role. And as Mark was saying, there's just so much to learn. And in fact, like if anything, like I would say that this, like right now in my current role, for example, like I feel like I'm kind of starting over again because I'm working with some completely new technology. We work with PySpark, on a managed platform called Databricks, and so this is like completely new for me. And even though I've been working for years as as a software engineer, now I'm just kind of having to to do that with a new technology. And so the bottom line here is that you're constantly learning, and don't be like you'll always be experimenting. Don't be afraid of like failing, because that's kind of part of life actually in general, and but that's how you learn, and you're always going to be like learning, becoming an expert, and then going into something new again. And if anything, I probably like your learning cycles are probably going to be a lot more faster than mine has been, just because I think technology is just evolving at so much of a faster pace now.
Thank you. All right, next we have Pragyan Nayak. Dr. Pragyan, please go ahead.
Thank you, Mike. Thank you, everyone, and good evening to everyone. Thank you for joining us, and thank you, Mike and Washington Statistical Society, for giving me an opportunity to be part of this panel. And it's been awesome listening to Mark and Prema, and to realize like how much our journeys are kind of similar but dissimilar in certain aspects. So it's always amazing, and I particularly enjoy panel discussions of this format. We're learning of somebody's journey, and at certain moments you're like, oh, that's exactly what happened with me. And sometimes it's like, oh, I wish I had done that. Coming to myself, I presently function as Chief Data Scientist with Hitachi Vantara Federal. I have over 22 plus years of experience, of which the last couple of years has been as a data scientist. I started off as a software developer, and it was only when I was deciding on which subject to pursue as part of my PhD program. This was way back in 2003. And as Prema mentioned, data mining was a term back then, which was very even for me, it stood out as a cool term. And I was also looking for an area where it would be more application oriented of computer science. My bachelor's was in computer science. So I was looking for something which is where I can get to do more application oriented stuff, and data mining sounded cool and something which aligned with that desire of mine. So started on that, and that is where plenty of statistics courses had to be taken, and that's how I got introduced to the field, and that's where my data science journey started. Meanwhile, I also started working as a federal contractor with one of the federal companies in the area. And so simultaneously, while working on my PhD, I was working on this product as a software developer. And that product was in the space of federal financial management. And that is where my connection to federal data started as well. So as you can imagine, my journey into both data science, which was called data mining back then, and the federal government data-based applications, and what is federal government doing with data, they went hand in hand. So with that, I would say I got a chance over the years, got a chance to work on a variety of data types. Of course, with that product we were working on, it was a federal financial data. So it had budgeting, accounts payable, accounts receivable, fixed assets, things of that nature, and getting familiarity with the federal government accounting processes and the data associated with it. And simultaneously on my PhD, I was working with astronomy data, which was galaxy data. And it was from the Sloan Digital Sky Survey. The data is available online and free. Most of these sky surveys, they release their data for free, so I could use that to look at the galaxy data and use machine learning to estimate redshift of galaxies using color information, morphological information of the galaxy, etc. So those were two unique, very distinct types of data I was working all simultaneously. It was a joyride. It was a lot of endless uh, nights without sleep, but worth it. Really had a good time. And ever since I've had a chance to work with waste management data. There was one project I did for EPA. It was a proof of concept where we got to explore the waste management data and look at one of the visualization tools and see how you could look at the patterns and trends in the data. And then I've looked at like packet capture data, systems level data, and look at how the network works when a new system is added to the entire organization's network and system setup. Um, and presently, I'm working in a role in a project which is more of a mix of data engineering and some data science in it. It's primarily in the space of records management, but we get to work with a variety of data sources such as files, email, SharePoint sites. So as you can imagine, the enterprise architecture in any given federal government agency is composed of these type of applications and systems. So getting all those data into one particular object storage platform and looking at the metadata associated with it, and then hopefully someday looking at the data science applications on all this data that is being organized and structured in a good way. So I would say there's a lot of learning involved. If you are a data scientist, you're always working in these various different domains. I enjoy working with the domain experts, understanding from them the niche and the uniqueness of that domain, and understanding what is the data science problem that they want to understand, and then being able to map that to a data sciencey problem, and what are the different tools, techniques, concepts which can be used to it. I prefer not doing the other way where I have a tool in hand and I'm like, hey, come on, try this tool, use this. And oftentimes that tool never gets used after I force them to use it. That's so that is something I always try to avoid. Always try to understand the problem and then come back to how do we best solve that problem and find the right tools and techniques and processes around that to help make that a long-term sustainable and more evolving solution over time. And with this, I'll pass it on to Alex.
Well, thank you, Prima. Alex, go ahead.
Hey, everybody. Thanks for having me, Mike, Montgomery College, Washington Statistical Society. Super thrilled to be here. My name is Alex. Like Mike said, I'm a data science manager at Accenture Federal Services. And before that, well, I'll start at the beginning. I graduated high school in 2000, and I was a jazz guitar major at a FAU down in Florida. And I was kind of like not wanting to do that. I was thinking at the time, my instructor, he was a guitar player, and he just seemed to like struggle a lot. And I just remember like, like, I don't know if being a musician, like if that's the life for me. And then September 11th happened. My father was in the military, and I decided that that was as good a reason as any for me to join the military. So I joined the military to fix helicopters. And I didn't like that either. And then an opportunity came up within the military to join the band. And I was like, I'll probably like that more. So I joined the band. After that, after those 4 years, I got out of the military and I was trying to figure out what to do with my life. And I was playing a lot of guitar, playing in bands down in South Florida. Then the Great Recession happened, and I got super interested in that. And that led me to get my economics degree, which led me to the Bureau of Labor Statistics. And I thought that was like the best thing ever. As an econ major, to get your first job out of college at the Bureau of Labor Statistics as an economist, I thought I was living the life. So I came up to DC. I was an economist working with the state and area survey. I did that for a couple of years. Then I moved over to the Department of Labor, where I was an unemployment insurance specialist, working with states there as well. Then I went back to the Bureau of Labor Statistics again as an economist, and I did that for a couple of years before I did the big career switch. And in 2019, I began doing data science formally with Accenture Federal Services, where I am now. So in all that journey, the one thing that all of this has taught me is to just be open to the lessons that you're learning at school, but outside of school, and just try and figure out who you are as much as possible, because what I have found in learning, specifically and learning quickly, because I've changed paths quite a bit, is to find things that interest you about about any particular thing that you're trying to learn. Like in data science, for example, if you're trying to understand natural language processing, it's super cool to like get into the nitty-gritty and learn what a specific model kind of does. But it's way more fun if you're able to, and the information is a lot stickier if you're able to apply that to something that you're doing. For example, like, you know, I remember struggling with some NLP concepts, and then taking those and being like, well, let me try to understand like Bruce Springsteen lyrics. Like, why not? Let me understand Joni Mitchell lyrics. That was, for me as a musician, that was way more fun, and I was able to kind of more quickly figure out what I was trying to understand, because I was applying it to something that I had a lot of interest in. And that goes for anything that you're learning. Yeah, so long story short, I got into the data science side of things when I realized that a lot of the stuff that I had learned in economics, my statistical classes and all that, when I realized data science is just statistical learning, then I was like, oh, I've been doing that for the longest. I can do that. And that kind of made the jump a little bit easier. The only other thing I'd probably stress, if you're trying to make a career out of data science and get people to pay you to do data science, in my experience is there's a lot surrounding the actual data science that you're doing. And I'm speaking specifically to like MLOps, so machine learning operations. So how do you have this model that you created, right? Where you're predicting something, whether it's fraud, like I do a lot of times, or whether you're trying to create a machine that makes lyrics if you find yourself in a fun job or whatever. But you have to figure out how to deploy that, how to get that to function. So understanding the handoff between the data engineer and the data scientist, and then the data scientist and the machine learning engineer, and the machine learning engineer to the folks that are actually going to put this all in process. There's a lot of handoffs and a lot of communication that's happening in that process. So understanding how to operationalize your idea and get it deployed is really important. I don't know how much of that is being taught. I know when I was an economics major, like they weren't really talking about any of that. But that's super important if you're trying to, like I said, get people to pay you to do this for a long time. Is like, it's one thing to come up with a cool idea or a cool model. It's another thing to get that out into the world in an efficient and and at least expensive way. So yeah, that's been kind of my arc there. And yeah, I look forward to hearing from the participants here, and the stories that you guys are saying were excellent. Man, Mark, I was going to mention, like, back in my day, like, I struggled. I didn't have like all these YouTube resources and all this stuff that everybody had. When you're like, I created this in Fortran, I was like, oh, okay, you got me beat, man. I've never, like, I remember, yeah, like picking up SAS and then picking up R when R was kind of getting popular, and understanding Python when it was like coming up, and like, you know, Stack Overflow wasn't as fruitful as it is nowadays. But yeah, your experience is awesome, and I'm super privileged here and honored to be here on the panel with you. Same thing, Prima and Dr. Nayak. Like you guys, you have, sounds like you have had incredible careers, and I'm quite honored to be on this panel with you.
Thank you, Alex. Okay, we got a great, we have some great panels here, and I would like to open the floor up to anyone, if anyone has any questions for our panelists. So feel free to either unmute, or if you wish, you could type your question into the chat for any of the panelists. Or if you'd like to allow all the panelists to speak on that question, that's fine as well. Go ahead, Rachel.
Thank you. Well, first of all, Mike, I wanted to thank you for organizing this. We're
welcome.
really grateful that you set this up because, first of all, thank you to all the panelists. You are incredible and you're inspiring. And so I just want to introduce you to who is here. So we have students who are both former data science certificate graduates and students who are currently in the program. We have biostatistics students here. We have Dean Milton Nash, the Dean of Math Statistics and Data Science. We have Professor Abdu Mohammed, who's also in the Data Science Department.
Welcome.
And so I wanted to let you know that you're speaking to kind of a very interested group of folks. And so thank you all for your experiences. And this is just more of a comment. I appreciate that you all navigated us through your interesting winding paths through to get to data science. And I think that's also helpful for our students. A lot of them have also had winding paths to get to Montgomery College from undergraduate degrees already and graduate degrees. And then they came back to Montgomery College for kind of that upskilling. And so I guess my question is, would any of you potentially be willing to be in communication after this meeting with any students if they wanted to ask you further questions?
Most definitely, definitely.
Wonderful.
Look forward to
Absolutely.
that.
Thank you. So if there's a way that maybe, Mike, if we can share anyone who's willing to share their contacts afterwards with any participants who might be interested in having that, I think you guys would be wonderful resources for everyone who's here. So thank you.
Sure, I would be willing to too. And actually this morning we had a mentor workshop. And if you go to the Washington Statistical Society webpage, you could be matched with a WSS member as a mentor mentee. So that could be another option.
All right, thank you.
And I would
Start.
absolutely be thrilled to work with and to help anybody out. I love getting people into data science.
Yeah,
Thank you,
likewise.
Alex.
Yeah, I mean, there's so much to learn, and I understand, like, there's just, I'm always happy to share, the things that I've learned over the years as well. So,
Excuse me, I have a question. It's kind of for Prima and Alex mostly. So I'm a student or a former student of Rachel's, and I went through the data science program at Montgomery College. I also got my AS in math and my associate's degree in computer science. And I got my original degree in anthropology and business back in 2012. But I've struggled a lot to get jobs since then. Like I've mostly had to do kind of like data entry, like very basic data analysis jobs through recruiters. And it seems like a lot of you, or at least like Prima and Alex in particular, like you guys kind of had, it seemed like your initial jobs, like you as a Prima, you as a data analyst at the startup, and Alex, you with your initial job at the Bureau of Labor. It seems like that kind of helped with the transition a little bit to data science. And I was just wondering, for those of us who haven't really had that like initial job to like sort of like catapult us, what would you recommend doing to like increase our chances of getting into data science? Like, would it make sense to start with a data analyst position first and then like slowly move into data science? Or like, just because jumping into data science, like I've been looking for many jobs now for like a while, and it seems very difficult to even get like an interview at this point. So I was just wanting to know your guys' thoughts on that.
Yeah, so I have some thoughts about this. There's a couple of things that I would recommend. One is get your hands on the keyboard and go. Like, it doesn't matter what you do. I mentioned Joni Mitchell lyrics. Like, just get experience and post your experience. There's no reason the world doesn't need to see your awesome analysis on Bruce Springsteen lyrics. Like, why not? Get it out there. Show that you're able to apply the things that you're learning in creative and cool ways. So it doesn't matter how small of a problem it is that you think you're trying to solve. Go ahead and solve it. If you're what was it I was thinking about earlier, like if you're you know, you can look up IMDb if you're like really into the Marvel universe, like do that. If you're into lyrics and music like I am, the Spotify API is fantastic. There's a ton of resources there. If there's like some traffic on your street that you think is super annoying, like that's data. That's something that you could figure out, and you can apply some of the stuff that you're learning and post that. Whether you're posting on LinkedIn, whether you're posting on Twitter, whether you're posting on your own personal blog, creating a portfolio like that people can see, I think is super important. And then with regard to getting started, yes, if you want, get started as a data analyst. When I started as Accenture, I just took, you know, I was thinking, I'm an economist. I don't have any like formal data science experience, but I kind of know what I'm doing. But I took it just a regular data analyst position within Accenture at first. But then I just kept raising my hand, like, I know how to do this. Like, I can do this. Like, I can do this. And then next thing you know, I get into the data science, and I'm now leading a team of data scientists. So like those sorts of opportunities you can make happen. Just say yes. And like I mentioned a little bit earlier, one of the things that was that's super important is this whole like MLOps idea and understanding how to operationalize machine learning and data science. I would say try and understand and get familiar with the ideas. There's a bunch of resources out there, but I would say that's super important. From my perspective, if you're trying to get involved in the, you know, in some sort of data science position, because whether you're raising your hand as to be a data analyst, if you're like really comfortable with Python and you want to be a data engineer or an ML engineer, if you're focused on that, whatever it is, you know, just raise your hand and you'll get the opportunity. Hope that helps.
If I can add a little bit to what Alex mentioned, as he was mentioning about portfolio development and data sources, one data source which I find very interesting is data.gov, where the various federal government agencies, they share their open data, and challenge.gov, where they post different challenges. So as part of your portfolio building, those could be certain experiences you can build up and share with them. Apart from them, there are events, online virtual events, which happen, such as Tidy Tuesday, which focuses on tidyverse applications. Makeover Monday is not on right now, but they have a lot of data sets and people who have created visualizations using those data, things of that nature.
Yeah, and
So, go ahead, Prema.
yeah, and then if I can add more on top of that, there's also Kaggle.com. So there is like machine learning competition so that you can participate in, and there's so many resources to kind of help you get started there as well. And again, like all the, writing a blog post about what you did, things like that can also, definitely, help you out. And also on the career front, I guess, like, in terms of trying to land a job, there are also like, lots of resources out there that kind of help you on that front as well. Like, there's resources online, there's podcasts, like there's one particular that I actually enjoyed because this lady kind of went through a lot of different aspects of like your career. It's called Dr. Dawn. She was, I think, the Wharton School of Business, I believe. And I think that podcast is getting a makeover at this point. I think it might be called something else, but there's like a lot of different topics that she goes over that could probably help you in terms of like the job search process and career development process as well.
And I guess just one other option, Mike does a lot of meetups, and you know, you could find ones you're interested in and then push yourself to give a meetup. And I think that's a really good way to connect.
Presentation.
Yes.
Mike, could you put the meetup information in the chat, please?
Oh, sure. Yeah, I'll do that. Okay. Are there any other questions while I'm looking for my meetup?
Pragyansmita, you're chief data scientist. When I think of that in the government, it seems like you would manage a lot of people, but it seems like you do a lot of hands-on work. So, you know, do you have a lot of management responsibilities? How do you get into it? How do you like it versus the hands-on data?
Yeah, that's a very good question. I like to remain hands-on. So, but my role requires me to be able to mentor and train people as well as identify opportunities that we can pursue with the federal government based on the tools and different processes and the resources that we have at hand. So I'm often like playing a balancing act between the two. I don't want to become hands-off. So that's the reason I try my best to keep working, being hands-on in the projects at work, as well as trying doing stuff on the side by myself. And sometimes there'll be a balance. At times I'll not be able to do the side projects and I feel like I'm running behind, particularly in our field where everything is, there's so much happening, so many new things, new concepts, new technologies, new terminologies evolving every day. You're always forever trying to play catch up, but at a certain point, you also have to determine your own your mental health as well as your family life, etc., and take that fine balance and be like, okay, this is enough. I can only do this much. I'll do this. But yes, it does involve a lot of mentoring, training, identifying opportunities for the team so that they can also grow and shine through the different works that they are involved in as well.
Thank you.
Thank you.
Is anyone here? Mr. Mohammed, you have a question?
Yeah, I am one of the instructors of the program. So
welcome.
My students go to Kaggle and get some neat, clean data sets, and they apply all kinds of models, scikit-learn and I don't know, PyTorch or whatever, and improve accuracy. But I think I would like to hear your experiences. Now there's also the trend, data-driven. So keep the model fixed, but work on the data quality, and you can get more out of that for your projects than keeping the data fixed and always improving a model by few percentage of accuracy. Yeah. So what do you think?
Or is that, I guess, any one of the panelists, if you choose to chime in to that question?
Sure, I can take a stab at that. Okay. So when we are working on a model, it's actually a balance between the two. As we get more data, we keep evaluating the model and then being able to tune that model so that it evolves with the new data that is available. And that is essentially what Alex has been talking about, the model ML ops, model ops, where it is about making sure the models which have been trained on an available set of data, how that evolves over time as more data is available, as well as you're increasing the accuracy of the model itself, and keeping track of those changes and keeping track of that history, that's important. And similar to model ops and ML ops, there is another side which is called the data ops, which is about keeping track of the processes and data changes which is happening as the data is being prepared. Keeping track, there's a term called data lineage, which is keeping track of how the data is changing, how a given field is changing as it moves through different stages of the data transformation, the different pipelines, etc., that are there. So that makes the whole data science application complex, and you can imagine why the teams are large, why it is not typically a one-person team which is handling this, because as you can imagine, you are having to take care of the data as well as the models, and around all this is the communication which needs to happen so that everybody in the team is aware of what kind of changes are happening in the different data applications that you have in place. That would be my 2 cents.
Thank you.
I'll stress what Dr. Nayak said about the whole concept. I know I've been really pushing the MLOps thing, but data governance is part of that as well, and it's difficult to kind of sell at times because especially when you're creating just like a brand new application from nothing, being the first data scientist on a project is probably like one of the toughest jobs, data science jobs that you could get, because not only do you have the responsibility of creating this thing, you have the responsibility of selling everything that goes into it to a whole bunch of people. And data science itself is not like a super mature thing, right? Where everybody just knows what you're talking about. Yeah, one of the things I think that's helped me throughout my career is, especially in the 8+ years I was at the BLS working with in state programs, state federal partnerships, is the communication skills that I acquired. So as a data scientist, that's so important, to be able to communicate the importance of things and get people to understand, whether you're trying to get them to appreciate what a strong data governance program will do for the whole operation, to why it's important that your training data is available and cleaned by a certain amount of time. Like data science and a machine learning operation, it doesn't just happen, right? It takes time. You have to iterate through things. So yeah, I just wanted to piggyback a little bit on what Dr. Nayak said there. Kind of drive that home.
Yeah.
Thank you, Alex. Go ahead,
So
Mark.
the statistical side, I can complicate. I think I spend 90 to 95% of my time doing data management, getting the data in the form that I need to analyze it, and cleaning it, and so on. So, and if the data were streaming, you have to, I guess, do the data governance and have that as a process. So data management and quality control are a huge part of the business for both of us.
Thank you all. I would follow up with the data governance. So we also would like to ingest data ethics into our courses. So how is privacy and fairness and explainability and such topics in your work when it comes to data governance? Yeah, thank you.
Yeah, they're all important. And what makes it difficult is these are not, there is not a recipe available where you're like, I put this in place and it's happening. So that makes it difficult, but definitely when you have defining a solution, privacy, ethics, explainability, all that has to be in some form or the other. And particularly when you're working with something which is a citizen service. But that being said, there are certain data applications where this may not be applicable. So having some way in which you're keeping track of data applications where these factors don't matter versus where it matters, and you want to focus on these aspects, that becomes something that you want to track and address in a timely and in a manner before it is exposed as a service for the citizens.
Thank
Yeah,
you.
And I
Go
can
ahead,
actually
Prima.
piggyback on that too. Like, I mean, I think kind of like how you mentioned data governance. I think, yeah, there's the whole notion of like, model governance or model risk management as well. And I think these are some of the things that in starting, projects like these, it is very important to kind of get all of the stakeholders involved and kind of coming up with a framework to kind of address these issues, and kind of like every time, we build new models, what are the questions that need to be answered, and how are, what are the potential risk points, potential areas of bias. A lot of, thought, sometimes needs to be put in, does, need to be put on this. And so kind of having that framework around and making sure that we have those, documented in place will help in that effort.
Thank you. So I am aware of the time, but I'm feeling that there's a need for a little bit more discussion. So I just wanted to check in with the panelists if it's okay to stay on just a little bit longer. But if you have to go, that's completely understandable. Is that okay with everyone? Okay, so we'll go on for a little bit more. And if you're choosing to, people here, if you want to go ahead and ask your question and to our panelists, until everyone here feels complete.
One quick thing I wanted to mention that I haven't. We actually the invitation for Montgomery College that you guys sent out went out to a colleague of mine that works in Accenture that went through the Montgomery College Data Science Certificate Program, and he wanted me to give a shout out to Dr. Mohammed and the folks at Data Montgomery for the capstone. He said it was really cool. It was really great, and I wanted to make sure I mentioned that. Yeah, you're well loved over here at Accenture.
Thank you very much, yeah, Alex.
Thank you, Alex. So are there any other questions for our panelists?
Yes, so I had a question.
Go ahead.
Yeah, so during your data science journeys, what were some of the hardest projects you had to work on, and what were some of the challenges you had to face?
I'll jump in and say, as a fraud focused data scientist, class imbalance is a persistent issue with us. So how do you create a supervised machine learning model when you have whatever it is, like a couple hundred fraud labeled observations and then hundreds of thousands of just regular ones? How do you create a good model against that? So dealing with class imbalance has been a huge issue. Learning how to implement non-supervised approaches is one way, right? Where you could take like an isolation forest, or you could take the approach of using like a k-means approach, where you create clusters, right? And then you create like a threshold around the cluster, and anything that's outside that cluster that belongs to that cluster, like we'll say that's fraud. Like, thinking creatively will take you very far in data science. There's a lot of problems that have yet to be solved and there aren't solutions for. And that's one of the things that I don't know, attracted me to data science, is just how much room there is for you to make an impact. So I'd say for me, one of the persistent problems is dirty, horrible data. Just nasty data is, like, I wish there was a world where all the data was clean and all I had to do was just run my models. But yeah, the hardest problems usually has to deal with cleaning data, dealing with things like class and balance, those sorts of issues. An analogy I heard a long time ago, or not a long time ago, but a little bit ago, was like, as a data scientist, you can think of like creating a data science operation as like opening a restaurant. And if you're just like opening a small restaurant, right? If you just have like a single Excel file, no big deal, right? The ingredients is your data. The tools are your cooking tools are, you know, your Python and R. You know, your recipes are, you know, your models, and then the food that you sent out is obviously the product there. And when you're dealing with like a 100,000 observation Excel file, no big deal, right? But and that's equivalent to, you know, you're just like a sandwich place. But what all of a sudden, like, what do you do if you're a restaurant where you're dealing with, like, I don't know, a couple tons of ice cream, right? How do you get the ice cream from from over here into your restaurant? And then once it's in your restaurant, how do you process it? How do you store it so it doesn't melt? How do you process it with the tools that you have available? And what recipes can you create with all this ice cream? Like, all of a sudden, it becomes like a much bigger issue that takes a bit more thinking. And that's where you start getting other people involved, whether you're talking about engineers and data governance and all this other stuff that we've been talking about.
Thank you.
Completely +1 to everything that Alex said. And I think a couple of things I'll add. One is when you're going through your data analysis and you start seeing certain results. When I started off, it was very difficult to figure out, is my result good enough? Is it something I should be reporting on? I remember the first result I had shared with my advisor. I just ran through it and he's like, hold on, wait, let me look into this. This seems like something interesting happening here. And so that was one thing. And second thing is, even if your result is bad, that is something good, that you know that this is not working. Knowing something is not working is equally important as knowing something is working. So that way, going forward, you will not be looking at it as a solution. So again, that is something in which my advisor had taught me, and I hold it dear to my heart till today. Because if something is not working, that's also good news. That's something that's a useful information to hold on to.
Thank you.
Does that help you with your question, Richmond?
Oh yes, it definitely helped.
Are there any other questions? Go ahead, Mark.
I guess I wanted to throw a different perspective. You know, we're interested in data and we're learning new techniques, and we'll look at the data and solve different problems. But in some ways, just having the data and analyzing it isn't going to give us a solution. And like where I've worked in the government, we've done this thing called structured decision making, where we get people that are involved in a different decision on different sides of the problem, like the government, public recreation, waterfowl hunters, and so on, and try to frame the problem. Oh, what are our objectives? You know, and obviously recreational users and business people, business leaders are going to have different perspectives, and then develop alternatives, see the trade-offs. And sort of the idea is what we try to teach in statistical leadership. And data science and statisticians, you know, they know all the technical things. And if they can learn how their organization is making business decisions, they can sort of lead from the middle, saying, here's what they're doing. Do, like, you know, your leader of your company isn't going to care about how you did the analysis. He's going to assume it's done right. but he wants to know what those results, how they're going to affect those decisions. And if you can think about these decision-making processes, work with all the people and communicate that to the leaders. The other part of it is you make, oh, how does this model work? What's the problem? Then you construct small data that's tailored to solving that particular problem. And then either monitor that or use that. So in some ways, balance, I'm not trying to throw a wet towel on everything, but think about the decision-making processes. And in structured decision-making, there's something called value of information. If you collect all the data in the world, but it's not going to change the decision you make, collecting and processing data is really expensive. There's no point in doing it because it's not going to change your mind. So think about how your analyses are affecting your decisions and learn how your organizations make those decisions. You can do that throughout your career. And I think that will give you a really good perspective on your work. So.
Thank you.
Feel free to ask questions or post in the chat if anyone has a question. Okay. So I don't see any more questions. So I will ask Rachel, is there anything else?
When's our next event?
Oh, I guess we'll talk about that.
I know, I'm just joking. But again, this was wonderful. So thank you again, panelists and Mike, for this. This is